This is the SelectFire Rapidstrike board. This guy gives you SelectFire control in your Rapidstrike or your custom-owned 3D printed blaster. It's super easy to assemble, probably faster than your standard Rapidstrike mod, and it's cheaper than the other solution on the market. This video will go over a physical overview of the kit itself, the features, the option for switches and how you want to control your flywheel motors, and its compatibility with the MOSFET board ecosystem. In future videos, I'll go over a full assembly walkthrough in a stock Rapidstrike, so that'd be from beginning to end, and how to install everything from the kit also to your flywheel motor, since this kit helps a bit with that. And I'll also have an in-depth overview in the future where I'll go over all the complex electronics and the software architecture behind the brains of this guy. First, let's go over what's actually on the board itself. This is one of the few PCBs available on the market, and this is probably one of the most complex, if not the most complex. Here's the board itself. It's in a kind of weird shape because it actually fits perfectly in a Rapidstrike shell. It sits right in the magwell, and upon closer inspection, there are these gaps here so it can sit flush with the shell, so you have these little pegs here that you won't need to cut off. And this actually doesn't obstruct magazine insertion at all. I chose this spot as opposed to above or below the jam door because oftentimes for Rapidstrike Uzi or pistol mods where you chop off the stock and you chop off the barrel, people like to place their batteries right here. So if I place the board up here, then trying to find a space for your battery becomes even more difficult. I have the advantage of the board being so thin that it fits right in the magwell as compared to other batteries that we use. If you want to assemble it, there are these holes right here that you can screw in that perfectly align with these built-in holes on the shell. And because this hole right here is so close to these solder holes over here, there's no metal around it. So if you're soldering, you don't have to worry about getting metal or solder on or around the hole. Starting off in the front, it's a white PCB. All my boards are white. And we have some holes right here that are for our high power stuff. This includes, as labeled here, the battery, the flywheels, and the pusher, which can be either a motor or a solenoid. We have here, these are the connectors that you'll be plugging stuff into. There's stuff like your SelectFire switch, your knob, your cycle control switch, your trigger, and your power switch. The stuff up here and these holes down here are going to be the main interactions you'll have with the board. And here is a pusher select switch. Not really a switch, you just simply put a little included jumper cap above it to indicate that you want the board to operate in solenoid mode, because this kit can do both solenoid and pusher motors. That makes it even better for 3D printed builds. Over here are some holes that break out some of the power rails and other stuff. So if you want to control more stuff with the Arduino, you can definitely do that. Everything's open source, so you can go ahead and program and add whatever stuff you want to add to the code, and even solder your own electronics. This right here is for the MOSFET board ecosystem, so you can plug and play other MOSFET boards to get even cooler features yourself. Moving on to the back, this is where it gets a bit more complex. You won't need to deal with this stuff, but it's a bit cool to go over anyways. Here I have a full-size Arduino Nano. It helps keep the costs of the kit low, and it also has a built-in mini USB to make easy programming. Here's a little buck converter that drops the voltage down from your LiPo battery to a safe for the Arduino battery. Here are some of the other electronics that you need for stuff like driving the motors, sensing the current, making sure the voltage is smooth, because oftentimes motors are very, very noisy, so you want your power to go to your Arduino as clean as possible. Let me show you how easy it is to install the kit. Here I have the board itself, and I just soldered a battery wire, which is super long, about 13 inches, because we want it to reach all the way out here to reach our battery. And I also have another one for the motor. This can be for the motor or for the solenoid, and instead of the XT60s I see used a lot, I like to use an XT30 for the pusher motor. The pusher motor only has one motor, so it's not drawing as much power as your flywheels, and it also makes wire management easier. The XT60 is quite a bit bigger, and that can be kind of tough to fit in this area, especially since it's so cramped and there are going to be a good amount of wires running through here. Notice how I'm using stock switches as well. This is good because it makes assembly a lot easier, as opposed to upgrading all the switches and having to carve out all this plastic around it and putting your epoxy putty down and everything. That's all a huge hassle to deal with. You totally can if you want, but it's just another option you can have. This kit is luckily compatible with both high ampere switches and these stock switches. That's because the board itself has MOSFETs built in, which means that we're using small power to control the big power that's used to power the pusher or the solenoid. So just do some simple wire routing first. Make sure the battery goes out to the left, and the pusher motor, I have these two holes side to side, which means that you can pull down the wire easier, and it should route right into this channel. Using thinner wires also helps because the shell itself is quite cramped, so there's not too much space to have thick wire everywhere. Simply lift up the trigger assembly. I've already assembled the wires for the cycle control switch and the trigger switch for demonstration purposes, and you want to plug in the connector from the board to the connector for the motor. But it also shows you how little soldering you have to do to get everything working. And once you finish soldering, it's actually really easy to get everything working all together. Let's put back the assembly for the switch. Notice how I only needed 2 connections for the pusher motor, 2 connections for the cycle control switch, and 2 connections for the trigger switch. And if you plug in these guys, these are both from the trigger and cycle control switch, and they plug in it's a solderless connection, and you just snap them in the board like this. These are the same connectors I used in the MOSFET board and the PWM board. These are nice because during normal operation of the blaster, it's going to vibrate a lot because there's so many motors and there's a lot of moving parts. So these connectors have little shrouds around them that offer a secure mechanical connection in addition to a secure electrical connection. So your switches won't be coming off anytime soon. I'll just plug in these 2 switches for now, which were the trigger and the cycle control switch. And that's really all you need to get it working. Once you turn it on, you can see a little red light down here, if you look closely. Because I don't have the select fire switch installed yet, it's only going to be in full auto. This board has built-in motor braking to ensure that your pusher always returns to its retracted state after every shot. And depending on your pusher motor, it's relatively easy to single tap. Notice how easy it was to get everything up and running. All I needed was 2 connections for the battery, 2 connections for the motor, 2 connections for the cycle control switch, and 2 connections for the trigger. That's a total of 8 connections to get super simple full auto mode. This is good as like a simple proof of concept to make sure everything's working before you go ahead and solder everything else. And it's also good if, let's say you have an event the next day and you spent all of today modding and you're sort of running out of time because you want to get some sleep before tomorrow's event. Well, if you don't have the time to solder everything else in the system, you can at least get a working blaster by soldering simple 8 connections and plugging them right in. Now let's see the select fire switch. If you look in the back here, I've already installed it. It's a simple rotary switch and it has 4 discrete positions. 1, 2, 3, 4. So of course one of them is safety, the other is semi-auto, then there's burst fire, and then there's full auto. Unfortunately, the switch isn't ambidextrous, so you can only strike it from one side. If you're left-handed, you can put it on the other side of the shell. I've also included this knob, so it's really easy to strike with one finger. Okay, not really easy, it's pretty easy. If you want, you can also 3D print your own little cap for this to make it more like a select fire switch so you can strike it easier with one hand. And that one has 5 pins and it's connected right back in. Super simple, just like the other ones. That's burst mode. Here's semi-auto. And here's safety. So of course nothing happens. And the last here's full auto. The burst mode is pretty good because you can just tap it and it's going to fire 3 shots. Also, if you're fast enough, you can simply do full auto basically with the burst mode. And if you're even faster, you can go for the full auto with single shot. I'm not fast enough for that. Now, there was also an option for a variable rate of fire. With that, you get a simple knob and its connector. There's a little connector here that says knob. Simply plug that in. Let's see. You won't see any effect in single shot, but you will in full and burst mode. So here's burst mode. It's a slower rate of fire. Let's crank it. That's the slowest rate of fire. Let's crank it all the way up. Notice how even though I didn't have the knob plugged in, it still worked. But if I unplug the knob, it only goes to the fastest rate of fire. Whereas when I plug the knob in, I get variable rate of fire. So I can do a little bit less, somewhere in the middle, and of course that applies to full auto. Let's take a second to point out the improved pusher algorithm. So notice how in the slowest rate of fire, it actually does max power to get the pusher out and back in, and then after it returns to its retracted state, then it waits a little bit depending on what the rate of fire should be. If the rate of fire is faster, it's going to wait less time in between shots. If the rate of fire is slower, it's going to wait more time. Slow rate of fire waits more time in between shots, and fast rate of fire waits almost no time in between shots. This is good because you get instant fire, you get instant shots out. So right when you squeeze the trigger, even if you're on the lowest rate of fire, you're gonna have a shot go out immediately. And there's one more switch I haven't populated yet, and that's the power switch. If you don't have a power switch installed and you plug in the battery, it's just going to turn on, and there's no way to turn it off unless you unplug the battery. But if you want the option to turn on and off your the system, you can go ahead and put in the power switch. This is an included switch. It's just a simple on-off switch. Go ahead and plug that in, and you're good to go. Here's off, here's on. If you look really closely, you can see the little red light that turns on and off. There's on, and there's off. Unfortunately, the board needs to be powered on to even turn on the pusher motor. So if you have the board off, there's really no point in plugging in your battery since you can't even turn on the pusher motor. It's just a simple nice to have feature that some people would like. Okay, that's enough about the select fire talk. There's also this board also has built-in overcurrent protection, which means that if your pusher gets jammed or stalled or something happens, you'll be less likely to kill your motors and to kill your jam box. Rapidstrike builders can be kind of annoying because sometimes you can get a pusher jam where the motor keeps trying to spin, but the pusher arm is stuck. In that case, you can either damage your motor and you can also break your pusher box. So this board will help prevent that. Of course, it's not recommended to try to intentionally stall your motor. If you stall your motor, it's still not good either way for the motor or for the gearbox, and if you stall it too many times, you can actually cause permanent damage to it. During testing and development of this kit, I actually stalled the motor for about 10 seconds. This was before I implemented the software Overcurrent Protection, so I just grenaded my gearbox, and one of the gears broke and I could never use the gearbox again. The motor was also toast. Now, this form factor perfectly fits the Rapidstrike, and it has all the little crevices you'll need. But if you want, you can actually install this into a 3D printed blaster. All you'll need are the 2 screw holes to mount them, and a trigger switch, and a cycle control switch. The cycle control switch is only necessary if you're using a pusher motor. A cycle control switch is a switch that is pressed when the pusher arm is in its retracted position. I'm working on different boards for different blasters as well. So that includes one for the Strife, because you can do solenoid in the Strife, and you can also there are also aftermarket pushers for the Strife. And I'm also working on one for the Raven as well. If there are any blasters that you want a kit for, like this, and there's a reliable full auto mechanism, I'll be happy to make one. Of course, everything for the kit that includes all the software and all the hardware for every single version, including the prototypes, is all available. I'll include a GitHub link in the description below, so be sure to star that if you have a GitHub account. This means that you can even make your own, you can order all your own parts and order your own PCB, which I have the files for online, and you can even make this yourself. You can also add cool little software features that you want all by yourself by reprogramming the built-in Arduino and adding your own stuff. Like maybe if you want NFC, so you can get your phone to talk to the board, you can add a little, and you can program your own little NFC module in addition to all this other stuff that's included and other cool stuff like that. Also, if you just want to learn more about electronics and software and stuff, this is definitely a good place to start. And lastly, this board has very little to no shell cutting required. Cutting the shell is one of the most annoying things, in my opinion, when modifying a blaster. In fact, I wrote a whole 26-page paper on how to use a MOSFET just because I don't want to cut stuff in my blaster. It's just really annoying and it gets stuff all over the place. It's all personal preference though. But for me, I really don't like it, so I've included special design considerations so you don't need to modify your blaster shell. This includes, of course, having the board fit perfectly in place, so you don't have to modify any other part of the shell to mount this, which means you don't have to drill holes that are perfectly aligned and all that stuff. All these wires are really, really thin, so you won't have too much difficulty routing them. There are only a few thick wires in the overall system. I've also added a little wire channel in the top, and that's going to be for your flywheel motors. You can do a little bit of shell modification around the area to make wire routing easier, especially if you're using higher draw motors that use more current. This is an optional shell cutting mark you can make, but the only required one is the hole you have to make for the select fire switch on the other side. This kit is actually compatible with solenoids as well. Solenoids are good when you're designing your own 3D printed blaster because they're easier to mount and design for, as opposed to a Rapidstrike gearbox. Most 3D printed blasters you'll see that use flywheels also use a solenoid pusher, just because they're easier to deal with electrically and mechanically. Solenoids are also good if you destroy or damage your gearbox. This is probably the most sensitive part of the Rapidstrike, and I often see these damaged through wear and tear or trying to use too powerful of a motor. They can also be damaged if you stall a motor, or if you stall a pusher motor. So if you have an old Rapidstrike with a damaged gearbox, you can still use the blaster actually. Previously, with a damaged gearbox, you were never able to use the Rapidstrike anymore. It was essentially just a $40 shell because there's no way to get the darts into the flywheel cage. But now, if you accidentally damage your gearbox, you can simply swap out the gearbox for a solenoid and you're back to normal. So I've plugged in the rotary switch, battery, solenoid, and the trigger. You don't need the cycle control switch because this algorithm actually uses calculus to fire the solenoid. If you have the variable rate of fire option with the knob, you can easily turn down the rate of fire to adjust for your solenoid. I would highly recommend using the variable rate of fire option because different solenoids have different spring loads and different power ratings. So some solenoids will be faster than others. By default, if you don't have the knob plugged in, you'll get maximum rate of fire, which may be too fast for your solenoid. Here's full auto. Reverse fire. And here's semi-auto. Let's talk about switches. Because this kit has built-in MOSFETs, you have the option to use the stock switches. If for some reason you don't want to, that's totally fine, and that's all up to personal preference. And this board will also work with your upgraded switches. So you have two options. You can either retain all the stock switches, or you can swap them all out. I personally think that it's easier to keep the stock switches because I'm more comfortable with electronics over mechanical mods. If you're more comfortable with mechanical mods and you feel comfortable drilling it out and mounting every single switch in place, you can also do that. If you use all stock switches, you'll need to use a MOSFET for the flywheel motors. Now you can solder your own MOSFET, or you can use your own MOSFET board, which makes everything a lot easier. And I'll go over how to do that a bit later. If you want to use all upgraded switches, you will not need a MOSFET for the flywheel motors. If this makes it easier, I'll put it this way. There is no high power flowing through the cycle control switch, and there is no high power flowing through the main trigger switch. There will be high power flowing through the rev switch, because this is going to control the flywheel motors. Remember that the flywheel motors are not controlled through the board, and you have to control them manually. That means through a rev switch, as it is traditionally done, or through a MOSFET. And you can find more info about this on my FAQ section on the shop page. So here's how I prefer to wire up the flywheel motors. I like to use a MOSFET board. I sell these on my shop, and these were the first products I offered. They allow for super simple flywheel builds, and I get to keep the stock switch since I find it very troublesome to carve out all this area for a rev switch. So super simple. I already soldered on the connector for the flywheels plus and minus. So we just have plus going to plus, minus going to minus, and we're going to pretend this is the batteries. And we're going to plug that right into the battery side of the MOSFET board. And you can use XT30s or Deans whatever you want for these, but the MOSFET boards include built-in XT60 connectors. There's an option for a master switch, but I usually don't use a master switch. Personal preference, so I plug in a jumper cap to bypass that. This is all included with the MOSFET board kit. Let's plug in the rev trigger. These are the same connectors that are on the SelectFire board, so the same amount of soldering is required, but I'll drop in the links in the description below for where to buy this in the installation video. And plug in your flywheel motors. Once you got that, don't forget to plug in our battery. And we're good to go. Now, if you want full versatility, you can get variable pusher speed and variable FPS using the PWM module. That's this guy. This guy is another part of the MOSFET board ecosystem. And to achieve variable rate of fire, so to achieve variable FPS, you just have to put the PWM module in a motor mode. So this PWM module offers either PWM motor control, which means you can get variable speed on your motor, or you can get SelectFire solenoid control, but you don't get burst fire. I'll leave links to this guy, of course, in the description below. That includes the store link where to buy it and the installation guide I made. There's text really close there. If you look on the bottom, it says motor, so I put in a jumper cap right there where it says motor. All these parts are included. I'll put in another jumper cap right here on these first top two connectors. I'll plug in the knob. The knob's included, of course. And lastly, I'll plug in the rev trigger, where the trigger goes. And this guy literally just stacks right on top of the MOSFET board itself. So you see those 3 pins in the bottom, you simply mate them together, and you're good to go. So if I pull the trigger, so in this case, you can actually hear the motors like becoming louder and quieter depending on how fast they're going. And there we go. You can just tuck this anywhere in the blaster, and you have the most versatile Nerf blaster you can get. You can get 170 FPS out of this guy. You can get a dart hose of like 18 to 20 DPS out of this guy, and you can change those. All those are all variables you can change with these knobs. And that's the benefit of this Rapidstrike board and all this ecosystem I've developed around the MOSFET board. So you can simply plug and play these things together, stack boards on top and connect boards together if you want more features. But if you don't really need those features or you don't want to pay the extra money, you can simply, everything works as bare bones as it can be. I'll also go over more of the ecosystem part in the in-depth overview of the Rapidstrike kit. So I'll show you how to use the expandable headers and how to program your flywheel motors to do a more complex control. And that's about it. Thanks for watching. I hope you enjoyed both the kit and the video. Be sure to check the description below because that's where I'll leave links for the MOSFET board 2, the PWM module, and where to buy this Rapidstrike kit. Stay tuned for upcoming videos on this kit. That includes an overall general assembly video, an assembly walkthrough from start to finish in a stock Rapidstrike, and an in-depth overview of the kit where I'll go over a lot of the hardware and software architecture and more technical details about the kit, and also how to program it a bit to take full advantage of the MOSFET board ecosystem. If you have any more questions, feel free to leave them down below. That's about it. Thanks for watching.